Welcome to today's lesson of Chapter 10. This example combines both 10.1 and 10.2, as most questions usually do on tests and finals. Chapter 10 is very Excel intensive. It always starts with creating a scatter plot or interpreting a correlation coefficient, something that you have to do in Excel. For Part A, it asks you to do a scatter plot. So you'll highlight your two columns of numbers. Go to the Insert tab, and the scatter plot of these middle 9 is in the bottom middle, and it's the very first one, the one with just dots, no lines or anything else. Now, many times you will create a scatter plot for a question in Chapter 10, but not actually need the scatter plot. If that were the case, then you could just move on from here and go on to Part B. This one does ask you to specifically create a scatter plot, so it is technically missing a few things. To fix those, click on the chart and go to Chart Design and go to Quick Layout 1. You can delete where it says Series 1. You can leave it if you want, but I always delete it to give myself more space. And it's given me places to label things. So the x-axis is carbohydrates. And put your units. These are all grams. And your y-axis is fiber, also in grams. And then for a title, put any other meaningful information that you have not mentioned. We have not mentioned that this is cereal. Specifically, it's Kellogg's cereal. You can, if you want to, put carbs versus fiber. Make sure if you include that label that you put the x-axis first versus whatever the y-axis is. So there's our scatter plot. It asks you to calculate a correlation coefficient. The label for that is R, lowercase r, is the sample correlation coefficient. And it is Correl, the first 6 letters of correlation. And then array 1, highlight the carbs, comma. Array 2, we highlight the fiber. So my correlation coefficient is negative 0.8087. But it asks you to interpret this in the context of the scenario. So there are different types of interpretations that you need. First off, we should be asking ourselves, is this linear? Now, I don't think that these dots make the best line in the world, but they're also not anywhere close to the worst line. So I can buy that, they're basically linear if I had some more points. Then ask yourself, is it strong linear? Is it moderate linear? Is it weak linear? This is certainly not strong. I'm not, 100% convinced that it's a line, but I'm pretty convinced, so I'll go with moderate. And then is it positive or negative? And you can answer that with 2 different things. Number 1 is looking at the scatter plot. The dots in general are going downward, and that means negative. Or you can look at the correlation coefficient. It is negative. Again, that's going to mean negative. So there is moderate, negative, linear correlation, between carbs and fiber in cereal. And I should probably say Kellogg's cereal, but it's probably all cereal. But then also tell me, what does this mean? What does all that stuff mean? And generally speaking, as the amount of carbs increases, the amount of fiber will decrease because it was negative. Part C, find the linear regression for this data and interpret the slope and y-intercept in the context of the problem. There are two different ways to find the equation. The slides give you a good job of doing one way. The other way is actually probably a little bit simpler, but it does require some steps that are hard to explain just on paper, but should be very easy in this video. So the other way is to pick any point on your scatter plot and right-click. And one of the options will be add a trend line. Excel calls it a trend line. We call it a regression line. And Excel will pop up with this box. It always defaults to linear, which is what we want. If you accidentally click on something else, make sure you take it back to linear. Down at the bottom, definitely do not check the box that says set intercept. That will get you in big trouble. But definitely check the box that says display the equation on the chart. You may choose to display the R-squared value on the chart. Personally, I like doing that, but I think occasionally it gets students confused because it's not the same thing as the correlation coefficient. So I'll leave it alone for now. And you can X out of that box. It always seems to put the equation in a place where I have trouble reading it. You can grab it and move it somewhere where you can see it. And this is almost your regression equation. It has one major flaw. The trend line, or the regression equation, is y hat. Equals negative 0.6271x plus 13.825. One request that I will have if you use this method to find the trend line or the regression line is that you use all of the decimal places that Excel gives you, whether that's 6, in this case 3 or 4, whatever Excel gives, use all of those decimal places. And it asks you to interpret the slope and the y-intercept in the context of this problem. So the slope is negative 0.6271. So for every additional gram of carbs, a box of cereal will have, not negative, we're going to use negative somewhere else, have 0.6271 less, there's the negative, grams of fiber. This is not going to let me, there we go. So there's our interpretation of the slope. So for the y-intercept, or sometimes they call it the vertical intercept, if cereal had no carbs, then it would have 13.825 grams of fiber. Now this is very implausible, but that is what the y-intercept means. Doesn't mean that that's reasonable, that it's going to happen, but that is the meaning. Part D, use the regression equation to predict the fiber in two different cereals, one that has 8 grams and one that has 20 grams. So I'll come down here, I think I have room. So these were predictions for the amount of carbs, which was X. I'm trying to estimate the fiber, which is Y. And there were 8 grams of carbs and 20 grams of carbs. So since they're asking me to predict or estimate, we're going to use our trend line. So -0 or plus 13.825. And after the -0.8271, there's an X. So we should have times 8, or I'll just click on the 8 that I already put in here. So we would estimate that 8 grams of carbs would have 8.81 grams of fiber. And we'll do the same thing for 20 grams of carbs. And this time we predict only 1.28 grams of fiber. So the last part asks you to find the residuals. Before you can calculate residuals, you first have to calculate predicted values. So in my column D, I'll set up the predicted values, and then in column E, I'll calculate the residuals. So the predicted is -0.6271 times X is the carbs, plus 13.825. And you can drag that down to get all of your predictions. And the residuals is the actual minus the predicted. So on this first row, the actual fiber is 2 grams. Minus the predicted fiber is 4.4 grams. It is perfectly okay to get a negative residual. In fact, in an ideal situation, you would have the same number of negative residuals as you do positive residuals. Also, in an ideal circumstance, you would have relatively small residuals. Many of these are relatively small. Some are not. This is not everything from Chapter 10, but it's a pretty good variety from Chapter 10. But please look over the MyStatLab questions, the lab manual questions. As always, if you've got questions of your own, please feel free to ask.